Hi students, welcome back to DuckFlix. Today we are covering lesson 7.7, area and mixed numbers. Please take a minute to review the lesson scale. By the end of this unit, we want you to be independent at using a model to find the area of a rectangle with fractional side lengths. Take a minute to pause the video and record your scale and number in your notebook. Let's take a minute to review some of the mathematical practices. First thing we need to remember is to make sense of a problem and persevere in solving them. We need to keep going. Don't give up. Next, we need to reason abstractly and quantitatively. We need to think to ourselves, what makes sense? We need to model with mathematics. We're going to show our thinking by using these area models. And we want to attend to precision. We want to always make sure that we check our work. Let's begin with the grid model for our first I do. Lucy's family wants to cover the rectangular floor of their kitchen with tile. The floor is 4.5 feet by 3.5 feet. Okay, so we have 4.5. Oops. Doesn't want to work. Okay, 4.5, and we have 3.5. And they want to use the fewest is a key word there, fewest tiles possible. And they do not want to cut any of these tiles. So if the tiles come in the 3 sizes below, okay, here are our choices, 3 sizes below, which size tile should they use? And we want to know what is the area of the kitchen floor. So we want to know the size of the tile that should be used, and we want to know the area of this kitchen floor. So the first thing we're going to think to ourselves is we are working in fractions of halves. So if we used the 1 foot by 1 foot tile, it would, first of all, it would not cover the whole floor, or if it did, it would extend past the floor area that we're trying to find. And if we decided that we wanted to try the 1/4 or 1/4 by 1/4 square tiles, they would fit, but they wouldn't be the largest. Okay, so we want to know what is the biggest size tile we can use with using the fewest. And so we're going to go with the 1/2 by 1/2 foot tile. We need to see how many squares are going to cover our diagram. Well, the area of 1/2 by 1/2 feet, okay, so the area of this tile is equal to 1/4. Okay, so each of these tiles is going to represent an area of 1/4 square feet. Now we need to decide how many tiles we're going to use for our model. Well, we're going to start with 3 1/2. Okay, we know that we have 1/2 by 1/2 feet, and if we have 3 1/2 of those, we would have, from our whole number 3, that would make 6 halves, plus 1 more half would be 7. So let's count 7. 1, 2, 3, 4, 5, 6, 7. And then we have 4 1/2 feet. Actually, I should have done my 4.5 feet across. So let's rewind for a minute. So 3.5, I did this backwards. 3.5 should be 1, 2, 3, 4, 5, 6, 7. And then if I had 4 1/2, we know that that is going to be 9 tiles, because there are 8 halves in the number 4, plus 1 more half is 9, and then we would go 1, 2, 3, 4, 5, 6, 7, 8, 9. And our model is actually going to take up this entire gridded area. And then we know that we have 9 tiles across, we have 7 tiles down, we know that 9 times 7 is equal to 63. So we have 63 squares here represented in our grid model. And we're going to multiply those 63 squares by the 1/4 foot that each tile is taking up, because we determined that 1/2 feet by 1/2 feet for each of these tiles is equal to 1/4 foot. So now we're going to do this over here. We have 63 times 1/4. And if we do 63 times 1/4, let me get my eraser so we have some room. Then we know that we are going to have 63/4. And then we're going to have to determine how many times does 4 go into 63. You can either do trial and error off to the side. I know that 4 goes into 63 15 times. That will make 60 with 3 out of 4 parts left over. So the area of the floor written as a mixed number is 15 3/4 square feet. I can write square feet like that. All right, now let's go on to using the area model. So we should be familiar with this. Let's think all the way back to our previous units, and we're actually going to take the same exact steps, but this time we're going to be working with fractions. So the first thing we're going to do is we're going to rewrite each mixed number as the sum of a whole number and a fraction. So this right here, our 1 3/4 is going to be written as 1 plus 3/4, and our 2 3/4 is going to be written as 2 3/4, or 2 plus 3/4, excuse me. Now I have the area model drawn for us, and technically they want these to be dashes because these are parts. And now we're going to place the 1 3/4 over here on this left side, and across the top we're going to place our 2 wholes and our 3/4. And we're going to use our knowledge of area model to multiply. So we know that 1 times 2, so we're going to multiply 1 times 2, and 1 times 2 is 2. Oh, that is not pretty. See if I can make it prettier. 1 times 2 is 2, much better. Okay, then we're going to multiply the 3/4 by our 2. And we know that 3/4 times 2 is going to give us 6/4. And yes, that's an improper fraction. We will come back and fix it later. Then we're going to now multiply our 1 by our 3/4. And we know with the identity property that anything times 1 is itself. So over here, we're going to have 3/4. And then lastly, we are going to multiply our 3/4 by our 3/4. And that will give us 9/16. And 9/16 is in the perfect denominator because we know that we have fourths, we have 16ths. And now we're going to add all of these parts up. So each section, we're going to add 2 plus 6/4 plus 3/4 plus 9/16. And we know that we can find a common denominator of 16. So we're going to make these 16s. We made them 16 by multiplying each of those 4s by 4. Remember, whatever we do to the bottom, we also need to do the top. So we multiply 6 times 4, we get 24. We multiply 3 times 4, we get 12. And now we need to add up the numerators. So we have our whole number 2, plus we have 24, plus a 10 is 34, plus 2 more is 36, plus 9 is 45/16. And now we need to ask ourselves, how many times can 16 go into 45? And it can go in 2 times, because 16 times 2 is 32, which means we will have 13 sixteenths left over. We cannot simplify 13 sixteenths because 13 is a prime number, which, remember, that means it has factors of only 1 in itself. We need to remember to add in our other whole 2. So our answer to this area model is 4 and 13 sixteenths. Okay, so that is the product of 1 3/4 times 2 3/4. Now it's time for you to try the problem. I want you to record this problem in your notebook, choose a model, either the grid model or the area model, and solve. And we will come back and check your answer. And we're back. Okay, so we have Oliver and Starbuck. Those are Miss Walker's kitties, and they want to tile the space under their litter box. I'm pretty sure they're going to need help. The space is 1 1/4 feet by 2 1/4 feet. We want to know what is the area of the space under this litter box. So I am going to show you with area model. And we would have go ahead and broken this up. Oops, this should be dotted. And we would have 1 1/4. We would have 2 1/4. We would have 2 up here. We would have 2/4 down here. And we would have 1/4 up in this top space, and we would have 1/16 down here in the bottom. Then we would need to add them all up, so we would have a whole 2 plus 2/4 plus 1/4 plus 1/16. We're going to find that 16 is going to be our common denominator once again. And so whatever we do to the bottom, we also need to do the top. We multiplied by 4 here, so 4 times 1 is going to give us a 4, and 4 times 2 is going to give us an 8. So we know that 8 plus 4 is 12, plus 1 more is 13. So once again, we have 13 sixteenths, but this time we only have 2 wholes, and that is in simplest form. So the space under the litter box is going to be 2 13 sixteenths square feet. Go ahead and reflect on your learning from this lesson, record where you are on scale, and we will see you in class tomorrow.